Okay, so we were doing question number 2, October 2025, paper 4 2. Okay, this question is saying that we have to store 20 unique random integers between 0 and 100 inclusive in a 1D array that is local to main program. Write program code to declare the local array, the main program, and store 20 unique values. Okay, so we have an array. We can call it anything. Let's call it maybe unique values, and this would be all empty, and it is supposed to have 20 values. So we can either set it to an empty array here, and then we can add 20 values in it by using a loop 20 times. So for I in range 20, like this, and then we can say unique values dot append some value, or the second method is that we can initialize it to 20 values by saying 0 for I in range 20. It simply means put 20 zeros in the array, and then we can go through the array, and instead of using the append function, we can go to each index and we can put a value there. So both of these are fine. So now the question, okay, now the question is saying that you have to put two values between 0 to 100 that are unique. Okay? So there are two methods. So the Python method would be to do a sample of unique values in the range 20. So we'll tell the range to be from 0 to 100. So this will go till 101, and we have to bring 20 values. Or the normal method is, if you don't know this function, then we have to do the how we do it using a while loop. That is that we will generate the values. So we will generate 20 unique values, and every time we'll do a reverse linear search. So let's set the count to initially 0, and then we check while the count is less than 20. So this is a 3-mark question. It could be a bit lengthy, but just in case you do not know how to use the sample method in the paper, because this is the first time they have asked you to do it that way. Okay, so while counting less than 20, then we'll generate a random number. So we'll say number is equal to random dot rand int from 0 to 100. So this will generate a random integer between 0 to 100. Then we also have to check every time if the value is unique or not. So let's call it unique, or the array name is unique values. Okay, so unique is fine. So we set it to true. We'll assume that the value would be unique. Now what we have to do is we have to make a reverse search in all the elements. So let's say if you have placed 3 values, let's say you have 3, 5 and 9, and then you're going to place the 4th value. So before the 4th value, you will compare the current generated value against 3, 5 and 9. If it doesn't match, let's say if it is 7, this value. So since 7 doesn't match with any of the previous values, then that means that the value is unique, and we'll place it in the array. So we set the unique to true. Now what we are going to do is wherever we have to place the current value. So like the example I wrote 4, 9, 8, and this is the value that we're going to generate. So from index 0 till the current index, that is where we'll run the loop for. We'll run the loop for I in range from 0 till whatever the index is going to be. So let's set the index to, let's change it to index, count to index, so there is no confusion, and we make it till index, and range will automatically subtract 1 from it. So this will run for 0, then 1, then 2. So it will only compare the current value with all the previous values. Okay, so now we check if this value that we have generated num, if this num becomes equal to any of the previously generated values. Again, so since we are at index, so this is index 0, 1, 2, 3, we're at index 3. So we'll compare the value that the number we generated, let's say, is 8. So we're checking, is 8 equal to the value at 4? Let's change back to count because we're using I inside. So count, and count here. So, okay. So we have to import random as well, import random like this. Okay, so we are saying that is the current value, is the current number equal to the unique value at I. So I is initially 0. So let's say the number that we want to store here is, let's say the num is equal to 8. The number that we generated is equal to 8. Okay, is it equal to 4? No. So that doesn't tell us anything. We go to the next one. Is it equal to 9? No. But is 8 equal to 8? Yes. Since that is the case. So we will instantly set the unique to false, which means that the value is not unique. And then what we have to do is we have to redo the random number calculation. So now we have to regenerate the number. Maybe next time we get 10. So then we'll recheck it. So is it equal to 10? No. Is it equal to 10? No. Is it equal to 10? No. So that means it is guaranteeing us that this is a unique value. So we put this in the array. Okay, so after the loop ends and we break out of the loop because we don't need to check further. So we check if the value of unique was set to true. That means if the value was set to true initially and even after running the whole loop, the value was never set to false, which means let's say if we have 10, so 10 is unique because it's not matching any of the values. Then and only then we are going to store this value in the array. So I'll say that the unique, I'll go and put the values at the index into of 12. So this is the num that we generated, let's say 10. So we're going to store 10 where at the current index or the count. So initially it would be 0, then 1, then 2 of the array unique values. So if we have 3 values, so I'll be putting the next value at the 4th index. Then if we have 4 values, then 1st index, then 6th, and so on and so forth. And then we'll increment the count by 1. So next time the value that we're going to generate would be here. At this question mark for the next index, and then I'm going to just print maybe. Don't really need to print it and just otherwise. So if it is not unique, then maybe we can say else that print the number already exists, or we don't even need to do that because the question doesn't say so. And then you print the value at the end. That would be print unique values. Okay, so let's delete this part and let's run it and see if it is working or not. So it should generate us 20 unique values, and I believe all of these are unique. So 8, 30, 11, 83, 56, 62, 45, 69, 2, 13. Okay, all are unique. Let's rerun this. So 97, 15, 40, 80, 25, 27, 86, 100. Yep, all of them are unique. Okay, so you can run it a couple of times, to make sure that they are all unique. So this will answer our question. Okay, first part. Then we move on to the second part, which is print array procedure, which will take an integer array as a parameter. The procedure outputs the array contents in a single line with a space between each integer. Okay, so to do that, we will just create a procedure. So this would be define. That should be above here. So define print array with this, and takes an integer array as a parameter. Let's call it unique values, the name of the same array that we generated. And then you are going to output the contents of array in a single line with a space between them. For that, we have to use the AND keyword. So I'll say for I in range, or because we just need the values. So for item or for value in unique values, just print the value directly without doing the index method, because we don't need the index in this case. And AND is equal to, and I'll put a space here like this. So this will override it will override the line break. So the values will not go to the next line, they will be printed in the same line. And let's try this quickly. Again, the question doesn't ask us to print it right now, but we'll just do it for our testing purposes. And yes, it prints them all in the same line. Okay, then we have part C, which says function is bubble sort, takes an integer array as a parameter, sorts the array in ascending order using a bubble sort, returns a sorted array. The function needs to work for an array of any length. Do not use any inbuilt sorting method. Okay, so this is very important. We have to write our own method, and then this should be efficient. Okay, even if it doesn't say that efficiency is not a concern, we still have to write efficient code because we're doing P4. That's only in the case in P2 where they don't really demand efficiency at times. Okay, so we'll write define bubble sort, and bubble sort will take an integer array. So let's again call it unique values. Okay, and then bubble sort, how does it work? It will compare the current value with the next value, and it will essentially using ascending order. So we just have to compare if the current value is greater than the next one. So for this, the mechanism is simple. We'll initially set swapped to false. We are going with the assumption that no swapping was done. Okay, just like we did here. We'll make an assumption, we'll run a condition. If the condition becomes true, we change the value, and then that's it. Same logic will apply here. And then we run a while loop while swapped is equal to false, or while not swapped, like this. and then we set the swap to, or maybe let's set the swap to, let's keep it false. So while not swap, while the value is being swapped, we set it to false, because this is just an assumption. So we are setting it to false initially, and let's set it to true initially. So the loop runs. Here we are checking, did a swapping happen? Yes, it means that the array is not sorted like this. So we are going with the assumption that, let's assume that no swapping will happen at this point. Okay, then we start using the nested loop. So we say for I in range for till the length of unique values like this, and then we say, okay, so we have the outer loop and we have the inner loop. Okay, so this will run n minus 1 times. The reason for that is because, yeah, again, you know this by now, if we have an array like this, so let's say we have 4 values, and if I try to compare the second last value with the next value, so this would be index 2 compared with index 3. But if I go all the way to index 3, then it will be compared with the index 4, which does not exist, right? So we have always done it n minus 1 times. So this is what we're doing here. Then we are going to check if the current value is greater than the next value. So if the index is 2, so the 2 plus 1 would become 3. So if the value at the current index 2 is greater than the value at index 3, then we're going to swap the values. It's very easy to do it in Python. You don't have to do the whole 10 thing. You can just do it in one line like this. So what are we doing here? We are just saying that whatever the current value of unique is, should be solved with the next value, and whatever the next value is should be solved with the current value. So comma separated value means that these two values will get solved with these two values. This happens at the same time. So this is very simple, and we set the swap to true. Now why did we set this? It means that the swapping was done, which means the array is not sorted still. So again, we'll go back to the loop. It will check while the swapping was done. Yes. So then we'll again go with the assumption that swapping might not be done in this case. And then we again sort through the array. So let's say if we have an array like 10, 20, and 30 like this. So since the 10 is not greater than 20, then 20 is not greater than 30, and then 30, so the loop will end. The value of swap would have remained false. And then when we go back to the while loop, since it is not true, so the whole while loop will eventually end. But if the value of swap was not set to true, so this will keep on repeating until the array is fully sorted. So that's the idea of this efficient bubble sort. And we get rid of the extra code. Okay, then, so let's also run this quickly, and we make sure that the code is working. So bubble sort unique values, and then we print the array. It should work. So yes, 4, 17, 19, 20, all the way till 95. And if I take, okay, so move to the next part. They are saying that now you have to write the main program. In the main program, you're going to output the contents of the array using print array. Okay. Then sort the array using bubble sort. Okay. And then output sorted and sorted contents. Okay. So first you print the contents of the array. So this is again the main function that we are in right now. We should label it main like this, and then print array. Then we have bubble sort, and then we are going to print array again, and it says that we should print the word sorted before that. Sorted. Okay, let's run this and see. So initially 2974 all the way till 93, and then on the next line it says it starts from 9 and goes all the way till 100. Sorted is printed in the same line because we had set the end to space. So in order to avoid this, we can just print an empty line by using empty print, and then it will go on to the next line and this line. So now the array is perfectly sorted, and this was the original array. Okay, next part they're saying that you have to write recursive binary search, which will take 4 parameters: integer, lower, upper, value to find. Recursive function performs a binary search. The function returns the index of the value that is found, minus 1 if it is not found. Okay, so this is again very simple. We just have to implement a recursive binary search. Again, you need to remember the rules for the binary search. So define recursive binary search, which will take 4 values. So integer array, which will be unique values, Then it says the lower bound, which would be start, then upper bound would be end, and the value would be called target. So what are the rules of binary search? In binary search, we start from mid index. If the target is greater than the value, mid value, then that means we need to basically move start to mid plus one. That means you go to the right of the mid section of the array. Else, if the target is less than the mid value, then that means we have to move to the left of the array. So we'll move the end to mid minus one, right? So let's say we are looking for 10, 20, 30, 40, and 50. So we start in the mid value, which is 30. And if I'm looking for 10, so 10 exists on the left of 30. So then we'll move our end pointer to 20, which is mid minus 1, and mid was initially 30. So that is what I'm going to. So we move end to end, else if they both match, then we are simply going to return the value of the mid index. Okay, and this will keep on going. So this will keep on going while the start is less than or equal to end, because there would come a point where if the value is not in the array, so end would end up becoming smaller than
सर आप
mid.
हम कॉल नहीं करेंगे इसमें क्या
क्या लिख रहे हो?
फंक्शन का फिर से रिकॉल कब करेंगे
हाँ, ये मैं सिर्फ अभी आपको लॉजिक एक दफा याद करा था, ये याद आ गई है ना?
ये जैसे ये तो याद है
ठीक है. So this was just the logic. Okay, now we have to write the code for this. So every time we also have to recalculate the mid value. So यहाँ पे हमने mid की value भी calculate करना है. Mid is equal to start plus, or you can just do start plus end double slash 2. This is the integer division. Okay, so it will not leave any fractional part. Okay, now we have to do it recursively. So let's start modifying the code. This has to be done recursively, so I'll get rid of the while loop, and then if start is less than or equal to end, then we are going to first find the mid value, and if the value is, let's say, okay, let's do the equal part first. So I'll just get rid of this comment code. I'll comment this was just for logic. So if the value, unique values, mid index is equal to the target value, this is the value that we're looking for at the mid, then I'm simply going to return the mid index. Okay. And if that is not the case, if the unique value is mid, if the target, let's say, is greater than the value at the mid. So like we discussed, so again, adding a comment here. If I am looking for 10, 20, 30, 40, and 50. So if I'm looking for, let's say, 50, so since 30 is smaller than 50, so I need to go to the right. So I'll update my start pointer. And what do I do with the start pointer? Start pointer would become mid plus 1. So this is mid. So then start will move here. And we have to do it recursively. So for that, I will make a recursive call. So return recursive binary search. Okay, now what will happen to the parameters? So the array remains the same. We are not going to change anything to the array. Okay, then start is the pointer that will be changing in this case. So what will happen is, since we are moving to the right, so start will become equal to mid plus 1. And that is what I'm going to do here. I'll literally just write mid plus 1. This will be copied into start next time. End pointer remains the same in this case. End remains the same. And then target value also remains the same. That's it. And else, if neither of these conditions are true, so that means we will return a recursive binary search call. And again, the name of the array would remain the same. No changes to that. Start will remain the same. So now this time, let's say I'm looking for 10. 10 exists on the left of 30, which means I'm going to update the end pointer here. So end will become to mid minus 1. So start remains the same. I'll send the same value, and then end becomes mid minus 1, and then the target value also remains the same. Okay, if this condition becomes false at any point, then I'm simply going to do else, and I'm going to return -1 because the question says so, that -1 will be returned if the value is not found, like this. Then they're saying that the main program prompt the user to enter an integer. Experiment.